Okay, welcome to my systems architecture for the BruceUber system. I'm an external student. So we've got a number of stakeholders in the BruceUber architecture. The first one being obviously the systems architect, which develops the details of the architecture. We have the software developers who develop the actual architecture, physically, so coding, and they also provide support and maintenance for the architecture. We have software end users, which include customers and employees. Customers obviously being the people who book the trips, and employees being people who drive the cars and pick up the people. We have some database vendors, which obviously just handle database servers such as SQL. And we have some finance vendors who will offer payment portals, for card payments and all that kind of stuff. And obviously, as a stakeholder, as somebody who just has a vested interest in the completion or realization of something, competitors can also be a stakeholder, as something like a local taxi company would go out of business if the BruceUber was to take off. So they're kind of vested in this, and unrelated companies such as maybe fuel companies or a service station might get a boost in business from the BruceUber being realized, so they're very likely to be another stakeholder, even though they're not directly related. So the pattern that's been chosen for the BruceUber architecture is a three-tiered pattern. We have a front tier, a middle tier, and a back tier. Front tier contains a user interface, which has been split into a customer interface and an employee interface. The middle tier contains the major functionality in processing, and it's been split into the general processing and the payment processing, and the back tier just serves the data access and storage, just the SQL servers, nothing much than that. We've used event-based style for the BruceUber architecture. Then there's three main events we've got. We've got the request strip. So obviously the customer interface they'll send their pickup location, their drop-off location, and their requested vehicle they would like. And then they could get an estimated trip price from this, so it's a bit of a branch off. And once this is done, it's stored in the database once they've requested it. And a driver can accept that job, which is the next event. So the driver, will send the driver details and the driver location from their employee interface, and then that will send, once they've accepted, the details and estimated time to the customer interface, letting them know how far away they are and all that kind of stuff, which is also then saved to the database. And then some more processing is done to get the driving route, and once the trip has been completed, the payment can be finalized, and then obviously the payment processing happens through that payment portal that we were talking about before, and the customer can receive a receipt through their customer interface. Obviously it's a little more detailed than this, but I don't have a whole lot of time to explain this. So I've also done a Darwin representation of the BruceUber architecture containing the front, the middle, and the back tier. So it's just showing how the data flows through the tiers, and you can't jump from front tier to back tier. You have to go through the middle tier, which does all the processing. So for example, the front tier, you send all those details like the custom pickup location to the middle tier, which is then saved to the back tier, which is then passed on through to the driver, the employee interface. So I can't explain all this, and obviously there's more to a Darwin representation with the bindings, but I haven't included them on the slide. They will be in the report. And I've got some examples of connectors here. So we have some event connectors, which serves as communication and coordination. Obviously the event connector, triggers the events and lets events know when other events are triggering and just coordinates them all. We've got a data access connector, which allows us to access that database and pull out that data and send it to where we need to. So that's a communication and conversion connector. And we have a procedure call connector, which serves as a communication and coordination connector, because obviously there's a bit of processing required with routes and all that kind of stuff. So these are some of the examples of the connectors. There'll be some more in the report that's handed up. And the new functionality that's been developed for the BruceUber is that you can pick up someone else before heading to the destination. And this is kind of interesting because you can take advantage of the split fare functionality, which is already built into the architecture, if the person you're picking up does actually have a BruceUber account. It's not that they don't need to have it, so if they don't have it, it's all good. But if they do, you could possibly split that fare as per normal. And this is interesting too because it requires a rerouting of the original/standard routes, because you might want to pick somebody up, after you've already established a destination, possibly. It's kind of a bit, it's a bit flexible. But yeah, this is a new functionality I've included or will be including in the report. So thank you for listening to my presentation.